Okay, 2.8 is graphing linear inequalities in two variables. So we've graphed lines already in this, yes, and we've graphed absolute value already in this. Now we're gonna graph them when they're in inequalities, like less than, greater than, less than or equal to, or greater than or equal to, which means we have to shade. Okay, but it's the same graphing that we've done this whole chapter. So, if you have, well, it's a which order here is the solution, but we're gonna figure out what the solution is here in a second. If you have less than, if you have greater than, you have a dashed line, yes? When we graph something, you have a dashed line. If I have less than or equal to, or I have greater than or equal to, I have a solid line when I'm graphing. And then we'll shade according to what fits the solution. Let's see here. How can I decide which of these options is a solution of the equation 3x plus 4y is greater than 8? Plug them in. What am I plugging in? The x and the y. Okay. So if I plug this in, if I plug these into that equation, which one allows for that statement to be true? If I plug a 6 into x, what do you get? 3 times 6 is? And then negative 3 times 4 is negative 12. What's 18 minus 12? 6. Is 6 greater than 8? No. If I plug in 0 and 2, I get 0, because 3 times 0 is 0, plus 4 times 2, which is 8. Is 8 greater than 8? No. Plug in negative 2. Negative 2 times 3 is? Negative 1 times 4 is? That gives me a negative number. It's not greater than 8. Negative 3 times 3 is negative 9, and 4 times 5 is 20, and negative 9 and 20 gives me 11. Is 11 greater than 8? Okay. So that is the first part of what you're going to do for your homework. Plugging in and then double checking. Okay? That's easy. The next part we're going to do is graphing. Okay? The graph of a linear inequality in two variables is the set of all points in a coordinate plane that represents solutions of that inequality. Okay? So, in the equation 3x minus 2y is greater than 2, anything that is in this shaded region will make this statement true. There's a dashed line because this is greater than, and then they shade on whatever side of the line is true. Okay? So we're just gonna pick a point, plug it in, and if it comes out true, you shade that side. If it doesn't, you shade the other side. Okay? But graphing is gonna be graphing the same way we usually do. Let's graph y is greater than or equal to negative 3. Where would I go to graph that? Y is y is less than or equal to negative 3. Where would you go? 0, negative 3. So I go 0, negative 3. So we're going to go 0, negative 3. So if I go 0, negative 3, 1, 2, 3, that's here. Is it dashed or solid line? Solid, because it says less than or equal to, so it's solid. And when I'm graphing y. Now, to figure out which side I shade on, I plug in a point. I'm going to plug in 0, right? No, I don't have a 0. Y is less than or equal to negative 3. Oh, I don't even need to plug in on this one. What solutions are less than or equal to negative 3? Do I shade down or shade up on this one? Down. Okay, this one you don't have to plug anything in. You just come over here and you shade down. Because anything less than or equal to this line will make that statement true. Okay, what about here? X is less than 2. Where do I need to go? 2, 0. 2, 0. Do you dot it or do you make it solid? Dot. Beautiful. And then we just look at this statement and we decide X is less than 2. Are the numbers less than 2 on this side or on that side? On the left side, so I shade this left side. I know, it's beautiful. Okay, so those are simple, very easy ones. Now we're gonna deal with a couple more that are a little bit more complicated. Okay, so this one says y is greater than negative 2x. Okay, that is in y-intercept form technically. Y equals mx plus b. What is my b? 0. Okay, my b is 0 here. So I plug a point at 0. What is my slope?
-2.
So I'm going down 2 over 1, yes? I'm gonna make this like this too again. So I'm gonna go down 2 over 1. So down 1, 2 over 1. Down 1, 2 over 1. Do I have a dashed or solid line? Dashed. Now, this is where I'm gonna plug in a point. I can't plug in 0, 0 because it's on 0, 0, one of the points. I'm gonna just plug in 1, 0, okay? Because my line doesn't go through 1, 0, I'm gonna plug that in. So if I plug in 1, 0, that means I get 0 is greater than negative 2 times 1. Is 0 greater than negative 2? Yes, so then I shade in that direction because the statement was true. Okay, do you remember doing this in algebra? Okay, now let's look at the next one. What do we need to do with this equation before we can even graph it? Mx plus b form. So it should say y, well, negative 2y, I'm gonna add that 5x less than or equal to negative 5x minus 4, right? Then I have to divide by negative 2. What happens when you divide by a negative 2? No. What happens to that less than or equal to? It flips. Do not forget to flip it. That's our main downfall, okay?
Isn't it just when it's negative?
Just when it's a negative, just when you divide by a negative, yes. So y is greater than or equal to 5 over 2x and then plus 2, yes? Okay. What is my b? What is my intercept? 2, so I go to 2, 0. I put a point. What is my slope? 5 over 2, so up 5 over 2. 1, 2, 3, 4, 5. We're gonna pretend this is perfect. 1, 2. Okay. Now, dotted or solid? Solid. You're just gonna be so much prettier when it's on graph paper. Now, I can plug in 0, 0 this time because 0, 0 is not something that my line goes through. 0, 0 is the easiest thing to plug in if you get a chance to do it. So 0 is greater than or equal to 5 seconds times 0 plus 2. Is 0 greater than or equal to 2? No, so I do not shade where 0 is, I shade away. Okay? Does that make sense so far? You can use different colors on your homework tonight, that might make it easier. Okay? So that's graphing linear functions. Okay, this says, a film class is recording a DVD of student-made short films. Each student group is allotted up to 300 megabytes of video space. The films are encoded on the DVD at 2 different rates, a standard rate of 0.4 megabytes a second for normal scenes and a high-quality rate of 1.2 megabytes a second for complex scenes. Write an inequality describing the possible amounts of time available for standard and high-quality video. Then we're gonna graph it, then we're gonna identify 3 possible solutions. What's my inequality? How do I write my inequality? Yes, Kate?
4x plus 1.2 mod there is less than or equal to.
Okay, so he took this, the 0.4, and he just put x with it, and then he said plus 1.2 y, decided to put y with that, makes sense, and it's, what'd you say, less than or equal to? And it's less than or equal to our total, which is 300. Beautiful. So there's my inequality. What do I need to do to that inequality to graph it? Yep. Get everything where it says y is less than or equal to this whole stuff, okay? So we're going to start by subtracting 0.4x. So you get 1.2y is less than or equal to negative 0.4x plus 300. Then you have to divide by 1.2. Y is less than or equal to, I don't know what 0.4 divided by 1.2 is, but I will find out. Oh, do you know? That's okay. 1/3. And then 300 divided by 1.2. Well, maybe if I could operate a calculator. Plus 250. Now, if I go to graph that, what do I have to do? Now it says to graph, what do I need to do when I graph it? Well, where's my y-intercept? 250. So we're gonna count by some big stuff, right? What do we wanna count by? 25, 25, 50, 175. Count by 50s. Count by 50s there, and on the x-axis, what do you wanna count by? Okay. So I need to graph 250, 0, right? 50, 100, 2, 50, 100, 150, 200, 250. Okay. And I'm going down 1 over 3, right? Down 1 over 3. It's going to be a very tiny graph. 3. Okay. Dotted or solid? Solid. Okay, solid. Technically, there's not going to be anything on this side of the graph, right? Okay, I'll even move this part of my graph over here. It's just like that. Okay. Now we have to plug numbers in. Guess what I'm going to plug in? 0, 0. It's so easy. So if I plug in 0 is less than or equal to negative 1/3 times 0 plus 250. Is 0 less than or equal to 250? Yes, so I want to shade down here, right, where 0, 0 is. What are 3 possible numbers that could work? 0, 2, what else? 1, what? 1, 0. 2, 100, any of those. You're just choosing 3 random numbers, okay, that fit in that shaded region. Now, last one, absolute value. Let's talk about absolute value in coordinate plane. Okay, now listen, this is y is greater than negative 2, x minus 3 plus 4, okay? Don't freak out because absolute value, we graph it the same way. What do we have to start with? What do we have to start with for absolute value? Starts with a V. Vertex, what's my vertex? My vertex is what? 3, 4. So I graph 3, 4. I start there. I'm not graphing this any different, except for I'm going to either make a dotted or a solid line, and I'm going to shade eventually. Otherwise, I graph absolute value the same as we did the other night. So I go 3, 4, 3, 1, 2, 3, 4. Okay, there's my vertex. Is it facing up or down? Down. Why do I know that? Because the negative 2, so that means it's also getting stretched by a unit of 2, okay? Now, what do I do to graph another point on my vertex, or on my absolute value graph? Can't just have a vertex, I have to have points. What do I do? No?
I just plug in zeros.
Just plug in something. I'm gonna just plug in 2, 0 because this is the point right next to 3, 4. I'm gonna plug in 2, 0. If I plug it in, that means I have y. Yeah, I wanna get y out. I'm gonna plug in 2. Y is greater than negative 2, and then 2 minus 3, the absolute value of that, plus 4. What's the absolute value of 2 minus 3? What's the absolute value of negative 1? 1. So 1 times negative 2 is negative 2. Or, yeah, and then negative 2 plus 4 is positive. So one of my points is 2, 2. I go to 2, 2, I graph a point. What do I do with this point? Mirror it. So it goes over here. Now, my vertex graph, is it dotted or solid? Dot. Dotted, it's just greater than dotted. Now, this is where I'm going to choose 0, 0, because it's easy. If 0, 0 is a true statement, I shade the outside of this V. If it isn't true, I shade inside, okay? So let's plug in 0, 0. If I plug in 0, 0, I have 0 is greater than -2. The absolute value of 0 minus 3. Okay, what's the absolute value of -3? What's 3 times -2? And what's -6 plus 4? 0 is greater than -2. Is that a true statement? Yes, so I want to shade where 0, 0 is. So it is the outside of this. Does that make sense? Okay, you need to have graph paper tonight for your homework. Okay, that is what you are working on. Shading and graphing inequalities. We've done both types of graphs, linear and absolute value.